This next section, we're going to revisit the idea of what molar mass and the weights mean stuff, but now for molecules. And if you hear the term molar mass, all right, that's like a molecular weight. What's molecular weight? Good question. Molecular weight is the sum of all the atomic weights of the atoms in the molecule. So earlier, if you have a periodic table ready, you can see, for example, hydrogen is about 1.008. That's the atomic weight. That means an average atom of hydrogen, 1.008 AMU. But like we talked about in the last section, the more useful way of thinking it is as grams per mole. So 1.008 grams per mole. Now, molecular weight would mean add up the individual atom's atomic weight. So for example, for water, you'd add 2 hydrogens and an oxygen. And the number you calculate basically has 2 meanings. The one meaning would be the weight, if you will, of an average molecule. But the more interesting one, and the one we're going to focus on almost exclusively, is the molar mass. And that's how many grams of the molecule you need to make a mole. Remember, a mole of anything is 6.022 times 10 to the 23rd, in this case, molecules. That's Avogadro's number. So the molar mass will allow us to go from something we can measure, which is grams, into something like a counting unit, which is number of molecules. It's pretty cool. Let's say that you wanted to figure out the molar mass of ethanol, C2H6O. Ethanol is drinking alcohol, so you have to be 21 and over in this country, 19 in Canada. No, I'm just joking. You can figure out how many grams per mole are in ethanol using this kind of thing. Now, in the last section, if we wanted to find the molar mass of oxygen, you'd look on the periodic table. Oxygen is about 16.0 to 3 sig figs, so that would be 16.0 grams of oxygen in a mole of oxygen. We're going to do the same kind of thing now, but for a molecule. So this is ethanol. It has 2 carbons, 6 hydrogens, and 1 oxygen. So each carbon on the periodic table to the 100th, 12.01 grams per mole. And we'll multiply that by 2 because ethanol has 2 carbons. This number right here, that's the grams from just the carbon. And we'll do the same thing for the other atoms in the structure. So there's also 6 hydrogens and 1 oxygen. Hydrogen, 1.01 grams per mole times 6, 6.06. And oxygen, about 16 grams per mole, and there's 1 of them, so 16. So if you add up 24.02 plus 6.06 plus 16, you get this number, 46.08 grams per mole. And that is the molar mass of ethanol. And that's an important number for chemists. If you have 46.08 grams of ethanol, you have a mole of ethanol. And a mole of ethanol, like a mole of anything, 6.022 times 10 to the 23rd. So in this example, you would have 6.022 times 10 to the 23rd molecules of ethanol. So it's a pretty powerful technique. And again, it's very similar to what we did last section. Now we're just adding them up all together. By the way, in chemistry, if you go to the 100th, like 12.01, 1.01, most of the time your sig figs, you'll be good to go. All right, you can go out farther. You can go to some of these periodic tables, you can go to the 1,000th or even 10,000th, and that's fine. But it does take more time to calculate the molar mass, and you probably have better things to do than doing that. So I'm just going to let you know, as a practical level, if you go to the 100th, which is what I've done here, you should be good to go. Also, each periodic table is a little bit different, so your numbers might be slightly different than some of mine. If you use the one that I recommended for the problem set, which is found at mhchem.org/PERTAB, PERTAB, for periodic table, you can actually get it. If you don't have that or you can't find that periodic table, let me know. But anyone will be fine. Also, you can find a molar mass calculator online or for your smartphone, and I do encourage you to get one of those if you can. We're going to do a lot of molar mass calculations, and you can absolutely do the process we just did, and that's fine. But if you're doing a lot of them, it gets to be kind of a drag. So a molar mass calculator is something you might want to look into. Tylenol, C8H9NO2. And if you figure out the 8 carbons, so 8 times 12.01, plus the 9 hydrogens, 9 times 1.01, plus the nitrogen, 14.01, plus oxygen, 2 times 16, you get 151.2. And for whatever reason, I only did it to a 10th here. Okay, weird instructor, but anyway, that's fine. 100th would be better, but a 10th is okay too. So you get the idea. And this is going to affect your sig figs. If you needed a 5 sig fig molar mass, you would not want to use a molar mass with only 4 sigs, which is what I have right here. So do be aware that sometimes you need to add more sig figs depending on what your calculation status is. Water, H2O, by far the most common of all the things we're going to look at, and you might as well start getting used to what the molar mass is. So let's calculate the molar mass of water. So you'd have 2 hydrogens, 2 times 1.01, plus 1 oxygen, and oxygen is 16.00. So to that magic hundredths, which I'm getting off on here, that comes out to be 18.02 grams per mole. Answer A. And we're going to use that number a lot. So the more you hear it, the easier it gets to be. Water is about 18.02 grams per mole. And again, you can go out more sig figs if you want, 18.015. You could also go less sig figs, like 18.0 would be 3 sig figs. But usually, like I said, to the 100th, you'll be good to go. So 18.02 is what I use most of the time. These are all 1 mole amounts. So for example, for aspirin there, it says 180.2. That represents 180.2 grams of aspirin. And copper 2 chloride dihydrate with a molar mass of 170.5, that's 170.5 grams of that compound. And iron 3 oxide, which is essentially rust, by the way, 159.7 grams, water 18.02. Now, the reason they differ so much is the density is so much crazier. Water, of course, has a density of about 1. Some of the other compounds are much greater, and I don't know them off the top of my head. But you're seeing different volume amounts depending on the density of the substance. But if you know the molar mass, you can figure out what a mole is. So each of those pictures there represents 6.022 times 10 to the 23rd molecules. So for the aspirin, that would be molecules of aspirin. For the water on the far right, molecules of water. People detect molar masses using a mass spectrometer, which is a really cool thing. This is a picture I showed in the last section. I'm just going to show it again. The picture right here shows how atoms were found, isotopic abundance. So those are all like neon atoms and the isotopes. But you can do it for compounds as well. This is the molar mass spectrum of ethanol, that drinking alcohol. Now, the molar mass of ethanol is 46.08 grams per mole. Notice that nomenclature, grams, moles, minus 1 means grams divided by moles. X to the negative 1 in math is like 1 over X. So mole negative 1 means like 1 over moles. So sometimes chemists will write grams per mole as grams moles negative 1. But anyway, molar mass 46. And notice how these lines here, which are like abundance, represents different parts. So there's actually a pretty good peak there for the version of ethanol without the H+, that is a little bit acidic. You'll learn more about this in organic chemistry. But if you can read these kind of things, you can find then the molar mass of your compound, which is pretty cool. Let's figure out how many moles of alcohol, which is drinking alcohol, ethanol, are in a standard can of beer if there are 21.3 grams of ethanol, C2H6O, in the beer. All right. Now, beer, like a lot of substances, has a lot of water, maybe hops or whatever. But in the can, there are 21.3 grams of ethanol. So let's use this information to find the moles. Now, to do this, we're going to need the molar mass of ethanol. And earlier, we saw that the molar mass was 46.08 grams per mole. So with the grams of ethanol and the conversion from grams to moles, which is what molar mass is, you bet that we can do this. 21.3 grams, our starting material. We want to make sure the grams cancel out. So 46.08 grams goes on the bottom, 1 mole on the top, to 3 sig figs. 0.462 moles of ethanol is what we have. Whoopie-doo, 21.3 grams. I don't know what 0.462 moles really means, whatever. Not that exciting. However, let's go the next step. So there's 0.462 moles of ethanol. I wonder how many molecules that might be. And you bet you can do this. This is what we did in the last section. You take the moles and you multiply by Avogadro's, because that gets rid of the moles. You're left with just molecules. Multiply those numbers together. 2.78 times 10 to the 23rd molecules. Now your 21.3 grams of ethanol is pretty small, but that represents more than 10 to the 23rd molecules of ethanol. Remember that 10 to the 9th is a billion, so 10 to the 18th would be a billion molecules, and this is more than a billion molecules of ethanol in your standard can of beer. So when you eat a sandwich, or you drink a cup of coffee, or beer for that matter, whatever, you're consuming just incredible number of molecules. It's just crazy how it is. But at least with these tools, you can figure out what it is and philosophize as to what they mean in a later time. But let's say you wanted to go a little further. So ethanol is C2H6O. And let's say that you wanted to figure out not just the number of molecules, but how many atoms of carbon there are. And that's a totally cool thing you can do with this kind of section too. So you've got 2.78 times 10 to the 23rd molecules of C2H6O. And if you look at that formula, ethanol has 2 carbons per ethanol. And this number, the 10 to the 23rd, is the molecules of ethanol. So if you wanted just the atoms of carbon, multiply that number by 2. And again, this 2 came straight from the formula. All right, that's where that 2 came from. If we would have been finding hydrogen atoms, we would have multiplied by 6 hydrogens per 1 molecule. Or we could have done oxygens, 1 oxygen per molecule. But anyway, for carbon, this comes out to be 5.56 times 10 to the 23rd atoms. So even more than that crazy number we had before. That's how many atoms of just carbon you're consuming. And if you wanted to take it to the ultimate spot, you could multiply that same number of molecules by 9, because there are 9 atoms in ethanol. 2 carbons plus 6 hydrogens plus 1 oxygen is 9. So you multiply that number by 9, that tells you that your ethanol has 2.50 times 10 to the 24th atoms. So when you drink a can of beer, and you're ignoring, by the way, all the water and the hops or whatever else, you're just focusing on the ethanol, the part that makes people drunk, all right, then in theory, you would be consuming 2.50 times 10 to the 24th atoms in that ethanol. And that's just crazy. Now, I said in theory because beers actually come with different amounts of alcohol in them, all right? Some of the fancier beers are, 8% or so, and some of the lower beers are much less than that. So this 21.3, I think, is probably on the low end, but you could calculate what your favorite beer was. And root beer, even, although you'd have to think about it as sugar, and I'll just be quiet.